Hello everyone, welcome back to Data Management. So in this session, we're going to discuss the second lesson that's all about hypothesis testing. So what is hypothesis or hypothesis testing? Let's start with hypothesis. A statistical hypothesis is a guess or prediction made by a researcher regarding the possible outcome of the study. It is also termed as a conjecture or a statement or assertion which aims to explain certain phenomena in the real world. And hypothesis testing is actually the process of making an inference or generalization on a population based on the results of the study and samples. It can be termed also as a test of hypothesis. It's a method to determine whether the statistical hypothesis is true or not. Okay, or hypothesis test. It is actually a statistical method that uses sample data to evaluate a hypothesis about a population. And there are two types of hypotheses. We have the null hypothesis denoted by H naught or H sub O, and the alternative hypothesis denoted by H sub A or H sub 1. So what is null hypothesis? Null hypothesis, this is a statement that is under investigation or being tested. Usually, the null hypothesis represents a data or a statement of no relationship, no effect, no difference, or put another way, things haven't changed. While alternative hypothesis is a statement you will adopt in the situation in which the evidence is so strong that you reject the null hypothesis. The alternative hypothesis states that there is a change, there is a difference, or a relationship, or an effect. Okay. And here is an example of a null and alternative hypothesis based from a given statement of the problem. Let's say our SOP is there a significant difference in the participants' academic performance when grouped according to profile variables? So how are we going to state our null hypothesis? So it can be stated as there is no significant difference in the participants' academic performance when grouped according to profile variables, while our alternative hypothesis can be stated as there is a significant difference in the participants' academic performance when grouped according to variables. Try this one. Okay, so given the statement of the problem, is there a significant relationship between participants' study habits and academic performance? Kindly try to state the null hypothesis and alternative hypothesis. So the answer is, or the null hypothesis can be formulated or stated as, there is no significant relationship between participants' study habits and academic performance, while the alternative hypothesis can be stated as, there is a significant relationship between participants' study habits and academic performance. So we need to know this term in hypothesis testing. There's what we call the level of significance. The level of significance is the probability of rejecting the null hypothesis when it is true. This is the probability of a type 1 error denoted by the Greek letter alpha. And usually we use in our results, we usually use 0.05 or 0.01 level of significance. There is also what we call critical value. Critical value is a test statistic value beyond which we reject the null hypothesis, often called a cutoff. While there's another term, critical region, also refers to the area in the tails of the comparison distribution in which we reject the null hypothesis if our test statistic falls there. The critical value is sometimes called the tabular value. Most statistical softwares use the probability value or p-value in making decisions. So what is a probability value? Assuming the null hypothesis is true, the probability that the test statistics will take on values as extreme as or more extreme than the observed test statistic is called the probability value of the test. The smaller the p-value computed from a sample data, the stronger the evidence against the null hypothesis. What is meant by the word significant? In statistical tests, a significant result means that the null hypothesis has been rejected, which means that the result is very unlikely to have occurred merely by chance. A result is said to be significant or statistically significant if it is very unlikely to occur when the null hypothesis is true. That is, the result is sufficient to reject the null hypothesis. Thus, a treatment has a significant effect if the decision from the hypothesis test is to reject the null hypothesis. Let us have an overview of the steps in hypothesis testing. So here are the steps in hypothesis testing. First, we have to state the null and alternative hypothesis. Second, we have to set the level of significance. We have to choose between 0.05 and 0.01. We have to compute the test statistics. And then we have to determine the critical value or p-value. And last, we have to make a decision whether to reject or do not reject HO. And how to make a decision using the critical value. So this is the decision rule when using a critical value. You have to reject the null hypothesis if the absolute computed value is greater than or equal to the absolute critical value. That in symbols we have this. And then we do not reject HO if the absolute computed value is less than the absolute tabular or critical value. In symbols, we have this. Let's have an example. Let's say the critical value is 1.96 and we computed a value of 1.275. So what will be the decision? Comparing your critical value and the computed value, we have do not reject HO because the computed value is less than the critical value. So this means that there is no significant difference between the two samples compared. We can also use the p-value in making decisions, and this is the rule. We have to reject the null hypothesis if the p-value is less than or equal to the level of significance. In symbols, we have that, and then we do not reject HO, or sometimes called accept HO, if the p-value is greater than the level of significance. In symbols, we have this. For example, using the p-value in making a decision, let's say we use the 0.05 level of significance and the probability value usually given by an statistical software. Like for example, we have this probability value 0.0012. What will be the decision? We have to reject HO. Why? When we compare the alpha or the level of significance and the p-value, we have the p-value 0.0012 is less than the alpha 0.05. Therefore, we have to reject HO. So when we reject a null hypothesis, it means that there is a significant difference between the two samples compared. So let us now discuss when to use some tests for significant difference and tests for significant relationship. So let's start with the test for significant difference, and here are some of the statistical tests. We have one sample t-test, independent sample t-test used to compare two means, the paired sample t-test also used to compare two means which are dependent, and we have the analysis of variance or ANOVA used to compare three or more means or groups. And we have to make sure before we can use all these tests, we have to make sure that our data should be in interval or ratio level of measurement, or simply they are numerical or quantitative like salaries, weights, test scores, and grades. So let's have some exercises on how to choose the appropriate statistical test given a sample statement of the problem or a results question. So let's say, for example, we have the SOP. Is there a significant difference in the academic performance of the participants when grouped according to gender? So what particular statistical test is to be used in this results question or SOP? So we're going to actually determine first how many samples or groups are being compared. So here is actually comparing two groups because this is according to gender. So we have two groups, male and female. And then we look into the variable involved or the data. It's about academic performance, and that is actually in terms of grades, for example, and that's in the racial level of measurement. And since we are comparing data which are ratio, two sets of data, we have to use independent samples t-test. So how about this SOP? Is there a significant difference between the height of nursing and education students? So just like the first SOP, in here we have two groups, nursing and education students. Our data is height, that is in ratio level. And of course, we need to use independent samples t-test. When we say independent samples, it's about it's actually we have two groups, okay, two separate groups, two different groups. So the group of the nursing and the group of education students are two separate groups. That's why they are called independent samples, and we use t-test here, okay. And in this SOP, is there a significant difference in the mean zone of inhibition before and after treatment of santan leaf extract? So we have here the word before and after. Okay, so we are comparing two means, but we have actually a clue. We use the word before and after, or maybe you can use the word pre-test and post-test, okay, initial and final. We can actually use the paired sample t-test, but make sure that your data should be numerical or in ratio level. So we have paired sample t-test. Let's have another SOP. So is there a significant difference in the students' test scores before and after implementation of the technology enhanced instruction? So we have two means here, the test scores before and the test score after the implementation of the technology enhanced instruction. And then we have actually our data. These are mean test scores, the pre-test and post-test scores. They are actually numerical or in ratio level. And since they are actually taken from just one set of students, we have what we call the before and after, getting from the same set, okay, of students or students in the same class. And we have the paired samples t-test. How about in this SOP? What's the appropriate statistical test to be used? Is there a significant difference in the participants' academic performance when grouped according to academic strand? Okay, so let's say we have here academic strand. So we have three groups or samples. We have the STEM, ABM, and HUMS. And our data here is academic performance in terms of grades, and these are actually numerical or they are in ratio level. So what statistical test is to be used? We have to use ANOVA or analysis of variance because there are three groups being compared. Three or more, we have to use ANOVA. If there are exactly two, independent samples t-test. And this SOP, is there a significant difference in the sales of fast food chains in Tuguegarao City? Let's say we consider the fast food chains Jollibee, McDonald's, Chowking, Greenwich. So there are actually four. Okay, so since we have more than three groups being compared, and you have to make sure that our data is actually numerical, that's actually sales or in ratio level. Therefore, we have to use ANOVA because there are four groups being compared and the data is in ratio level. And we're done with test of significant difference. Let's proceed now to test of significant relationship or association, especially if our data are in nominal or ordinal data. They are categorical or what we call qualitative data, such as gender, nationality, educational level. And the test to be used here is what we call chi-square test. So instead of using means or averages, we are going to use here frequency or counts. An example of a statement of a problem wherein chi-square test is to be used is this one. Is gender related to course preference? That is actually the same with this statement. Is there a significant relationship between participants' gender and their course preference? Or you can also restate it as, is course preference dependent on gender? All these three statements are actually the same. They have the same meaning. Okay, they mean the same thing. Okay, and data in chi-square test can be written like this in what we call contingency tables. There's a row and column for the two variables. We have the gender and the course preference, and we know that these two variables are in nominal or ordinal, or they are called categorical or qualitative data. So we have just learned that chi-square is actually used to determine whether there is a significant relationship between two variables if these variables are actually nominal or ordinal data. But how about if our data are in ratio or interval data? So to test the significant relationship between two variables which are ratio or interval data, we use the Pearson R. So here is an example of data or statement of a problem wherein Pearson R is used. Is there a significant relationship between the student's study time and test scores? So to actually organize your data in a Microsoft Excel or even in the SPSS, you have to arrange it like this. You have the first column for the participants or student number, and then you have the second column for the first variable, that's study time, and the second column for the second variable, or I mean the third column for the second variable test score. So in this SOP, is there a significant relationship between the participants' study habits and academic performance? So we have to make sure whether study habits is being actually measured in ordinal, nominal, interval, or ratio scale, or even the academic performance. So what particular data you're going to collect. So for study habits, let's say, for example, you want to collect the data through a Likert scale questionnaire wherein it gives you weighted means like 4.52, 3.48, and then for the academic performance, you want to actually collect or gather data about the grades of the participants like 90, 86, and 89. And these data are actually in ratio level. Therefore, if data are in ratio level and you want to correlate or relate these two variables, we need to use Pearson R. And look, we have the same SOP with the previous. Is there a significant relationship between the participants' study habits and academic performance? But this time, we're going to collect, okay, instead of numerical or quantitative data, we need to collect qualitative data. So instead of numbers, we want to have levels. Like for study habits, we want to just classify or actually describe our participants as to having a study habits of poor, excellent, up to excellent, and even for academic performance starting from poor to good, satisfactory, very satisfactory to excellent. And these data are no longer numerical or quantitative, but they are ordinal level. And if we want to associate or to correlate variables which are ordinal or nominal, so instead of using the Pearson R, we need to use the chi-square test. And to check your understanding about this lesson, you have to actually answer this exercise here, and we are going to check your answers in our synchronous session. So may I just read? For each statement of the problem, determine the appropriate statistical test to be used. Is there a significant difference in the mean test scores between the female and male participants? Is there a significant relationship between participants' gender and educational level? Is there a significant difference in the number of COVID-19 active cases in the four cities? Is there a significant difference in the participants' knowledge before and after the seminar training? And is there a significant relationship between participants' well-being score and resilience score? And that's all for this session. See you in our synchronous meet. Okay, God bless and stay safe.